I have a circle and I have a different sort of shape. Looks like a right angle. And I want to know the area of the shaded region. Okay. I'm also given, so the radius of the circle is 6. So this radius is 6. And I want to know the area of the shaded region. So here, and this is sort of a common problem on SAT geometry problems, is that I don't actually have all the figures that I need to solve. So on the last problem, we wanted to subtract some area from another area to get the area of the shaded area. And that is sort of a general idea with shaded problems, is that we want to subtract two different areas. So in here, I really need a square to subtract from, and I guess my other option would be to try and create some triangle, but that looks like it's going to be a lot harder, and it is going to be a lot harder. So this is sort of a getting better as you go type thing, but you're just going to have to be able to see that you need that square. So if I draw in a square here, though, the one thing that's helpful to me is that both of these two sides are radii. So I know that this side is 6, and I know that then this side is also 6 because it goes from the center to the outer point. So I actually can find out my larger area, and I know it's my larger area because it actually includes the shaded area, while this part of the circle doesn't. So my square is just going to have an area equal to 6 times 6, or 36. But now I want to get an area that I can take away from that square. And basically, I can see that if I have a square, then all of these angles are 90 degrees. So if I look at 90 degrees worth of the area of my circle, then I could get just that fraction from the whole of the circle and take that area away, because that's what I want to take off from the square area to get just the leftover of the shaded area. So here I have the area of the circle is pi times 6 squared. So that totally would be 36 pi. But what I'm looking at is only a quarter circle. And if I were to go back to the equation that I previously mentioned, which is that basically the degrees that we're looking at over 360 is equal to the part over the whole, I could say that 90 over 360 is going to be the part of the area that I care about, which is a quarter circle, because 90 over 360 simplifies to 1 over 4. But it's going to be, so the area that we care about, that part over the whole area. So 36 pi, and I end up with the part equaling 36 pi. I just multiply both sides of the equation by that. And I have from there that this is equal to 9 pi. And then for my shaded area, which I'm going to shorten as SA again, that's just going to be, so my square minus my quarter circle, 9 pi. If I do that in my calculator, I'm going to get something like 7.72. So now I have that shaded area. So this is really breaking down circles and the other shapes that you're given, and then also using this relationship again, that circles stay proportional in terms of both area and circumference. So those are sort of the keys to solving circle problems on the SAT. Hopefully this video has been helpful, and join us in future Educator.com SAT math videos. Thanks.